Hello everybody, in this video we are going to discuss about motion under gravity. So it is not a new topic as such. You can treat it as a special case of uniformly accelerated motion, something that we have already discussed in the previous lecture. You can check out that. I'll suggest that over here. You are supposed to know the three equations of motion and the convention, okay? So that you can proceed with this. So let's begin with today's topic, which is motion under gravity. So as I said, it is a no new topic. It is same as it's a special case of uniformly accelerated motion. So in this case, the acceleration will be minus g. You know what this g is? This g is acceleration due to gravity, right? Due to gravity, you'll know it from your lower classes. You'll also know its value. Like when I suppose I drop this thing, I leave it from here, right? It gets pulled towards the earth due to a force. You'll know it, gravitational force, and the acceleration due to that gravitational force is called g, which is acceleration due to gravity, right? Acceleration due to the gravitational force, acceleration due to gravity. So minus because it's in the downward direction, right? It is pulling the object towards the earth, downward direction, and we took the downward direction by the regular convention to be negative. Remember the conventions, previous lecture? Yes. So downward, and that's why it's negative. So something of this motion in which this force, this acceleration exists throughout its journey. So you'll have an object which is thrown up, thrown down, object which is left from a tower. So some examples of motion of gravity I'm giving you. This g has a value which is 9.8 meters per second square. You'll know it. So this value keeps on varying as you go higher and higher up or deep down. Like if you're closer to the earth, it won't change. So you can assume it constant if the distance is not like as comparable to the radius of the earth, okay? For small distances, the value is constant. Or you can approximate it, like they'll mostly approximate it to 10 meters per second raised to minus 2. 10 meter second raised to minus 2. So for making calculation purpose easy, they'll approximate it to 10. Otherwise, it's 9.8. Unless specially mentioned, take it to be 9.8. So that was the introduction about motion under gravity. So let's discuss a problem. So you can brush up your equations of motion. So suppose there is an object which is thrown up, like suppose this pen is thrown up with a speed of 4 meters per second. So it's thrown up with 4 meters second raised to minus 1. So they have asked for finding the max height, maximum height at which the object reaches. Maximum height, right? Only this much amount of data is given, and you know, obviously you'll know that acceleration due to gravity is there throughout the journey, and it is 10 meters. They have taken it to be 10 meters second raised to minus 2. Find max height, okay? Find max height, and if you try, you'll be able to do it if you know the equations of motion. Okay, so what will happen? What happens at the maximum height? You can see that it goes to the maximum height, it stops because its velocity goes on decreasing, because see, this acceleration is in the opposite direction, so it's retarding it, right? Its velocity will go on decreasing, then it stops. When it stops, it is the maximum height. See it, when it stops, it is the maximum height, and then it returns back. So from here you have to go till the point where final velocity is 0. It begins with 4 meters per second. It stops at the highest point of its journey, which is the maximum height. So final velocity is 0 at the maximum height. You can see that. So one more data you got. So now you can use your equations of motion and find the maximum height. Which one will you use? So v you have, you have, acceleration also you have. You want the maximum height, use this thing, v square is equal to u square plus 2as. Let's take the upward direction to be positive and downward direction to be negative. You can also flip it, same answer you'll get. Okay, logically the same. Okay, v square. So final velocity becomes 0 when it reaches the maximum height. U square is 4. So 4 in the upward direction, and square it. So 16. And you have 2. A is minus 10 downward direction. Okay, minus 10. And S, which is the height that you want to find. So let's name it H. You can see that it will be in the positive direction, though you don't have to substitute the sign here for the variables. So 20 minus 20 is equal to minus 16. So 16 by 20. So minus sign got cancelled. Okay, 16 by 2 is 8. 8 and shift a decimal, 0.8 meters. Yeah, 0.8 meters is the correct answer. So maximum height it reaches is 0.8 meters. So now you'll ask me, I am still able to do the problems of motion under gravity without learning a single thing, right? We didn't begin with learning a single part of the theory. So why am I supposed to learn it? So I'll give you some reasons. One among them is you'll practice your equations of motion, right? You can practice it this way. Two is I'll give you some shortcuts, like we did it in a very big way. We can do it in one single step, like we directly do this step when I give you the shortcut. Okay. Third is like there are complex problems also appearing in the exam, so you'll be able to solve those after this lecture. Okay. So there are complex problems. Motion under gravity is one of the best topics from kinematics. So yeah, you can note that down. So you are able to solve the questions without learning theory. Okay, so let's learn the shortcuts first. Okay, let's consider the first scenario when the ball is thrown up or the object is thrown up, right? So when an object is thrown up, so in this case what will be given is u. So initial velocity will be given. So with whatever velocity a person is throwing that object will be given. So this is given, will be provided in the question. And what else will be given is the u and thrown up, right? So you will be asked to find the h max, maximum height. Obviously g is given, acceleration due to gravity, you know it. And you'll be asked to find the time. Okay, so yeah, and you can take that final velocity to be 0, because finally when it reaches the maximum height it stops and then it changes its direction and comes down, right? Gravity is down always. So first it slows down the motion, slows down the speed in the upward direction. Finally it stops at the highest point and then speed increases in the downward direction. That is what happens. So you'll be told to find h max and t. What is the height, maximum height to which your object reaches, and what is the time taken to reach that height. Okay, what is the maximum height your object reaches and what is the time taken to reach that height. So your u is given, g you know, v will be 0. At the highest point v will be 0. So can you use an equation of motion, v, u, and yeah, the same one, right? V square is equal to u square plus 2as, right? So v is 0, so 0 square 0. U is given, so we'll substitute it. Suppose the ball is thrown up, right? U, and you have g, we'll draw that because of the conventions. We'll also substitute the conventions. So upward is taken to be positive, so u is positive. 2a, a is minus g, negative, right? Downward is negative, minus g, and s is the distance, right? When final velocity becomes 0, what is the distance? H max, maximum height. At maximum height final velocity is 0. So you can note that h max. Now solve for h max. H max is u square by, so this goes there, negative sign goes, right? When you bring it over here, negative sign goes, u square by 2g. Okay, so these two formulas you need to know. I'll tell you for the time it takes. Anyways, now if you remember the previous problem, you can now do it in a single step. Now just substitute over here. The ball was thrown up, u was given, g was g you know by your knowledge, and v was 0 at the highest point, right? So they had asked for h max. Now you can directly do that, right? Ball was thrown with 4 meters per second, 4 meters per second, so 4 square upon 2 into g. G was taken to be 10, so 16 upon 10, 16 upon 20, which is 0 0.8. Same answer, right? Yeah. So this is the shortcut, not shortcut as such, but yeah, it's the formula to do it quicker, right? So that is how h max comes. Now let's go for t. Okay, you can note that down. From from where did h max come? Okay. Now for t, for the time to reach the highest point, time of ascent, we call it time of ascent. Remember that, time of ascent, time of ascent, time taken to reach the highest point, highest maximum height basically. Okay, time of ascent, it's ascending up, right? So what is the time? So finally, you know the velocity is 0. This you know, you can simply use v is equal to u plus at, right? Now u is given, so which is in the upward direction, positive. G is minus, negative, minus g, and t we want to find, v is 0 at the highest point. Okay, so t is equal to u by g, right? This will go there, so positive, u is equal to gt, t is equal to u by g. So t is equal to u by g. Simple enough, right? Simple, easy. Time of ascent is u by g. One more thing that you have to keep in mind is we have already substituted the sign conventions, right? We already took g to be negative, u to be positive. So you need not consider it again, right? You should not substitute sign conventions over here. Directly use the formula, directly substitute the values. Don't substitute with sign over here. Directly substitute the magnitude, okay? I'll write that down. Substitute VUA as magnitude only. So you have to substitute the magnitude only, because sign conventions we have already considered while deriving this result, right? Yeah, and now when we throw an object up, right? When we throw it up, it goes up, it stops, and it comes back. So can you find the total time of flight? From here it began, it went to the highest point. This is the journey, right? Total journey, how it is going to happen. So it began with u. Can you find the total journey time? Basically it will be the double, right? Because one more point, very important point, upward and downward journeys are symmetrical. Okay, so whatever happens in the upward journey will happen in the downward journey as well. So upward journey, the time was u by g. What is the time for downward journey? U by g, symmetrical, right? And this is called time of descent. Okay, descent. How do you spell that? Descent, I guess it's correct. So time of ascent, time of descent, which is total time, time of flight, time of flight. So note down this formula, because so you have to add this two times, u by g, u by g, u by g to go up, u by g to come down, so 2u by g. Okay, so we derived each of the results. So three things to keep in mind, like first the formulas, all the formulas, and yeah, h, t, time of ascent, time of descent, total time of flight. Okay, then don't substitute with the signs, only substitute the magnitude. Okay, like g, you don't take it minus 10 over here in this formula, you take it just to be 10, only magnitude substitution, because we consider that in while deriving. Upward and downward journeys are symmetrical, so time of ascent is same as time of descent, and this is when there is no air resistance. Okay, no air resistance. Okay, so if there is no air resistance, which we are neglecting of course in this case, so upward and downward journeys are symmetrical. Like suppose if I had to give you a feel, see, when there is air resistance, the time of descent will be greater. Like when I throw this paper up, when I threw it up, it went up fast, right? And while coming down, it is like, right? So time of descent becomes more in that case. So we'll come to that in non-uniformly accelerated motion. But since the discussion today is about a special case of uniformly accelerated motion, which is motion under gravity, we are not going into that. Okay. So for today, it's time of ascent equals time of descent. If there is no air resistance, here also I'll write. Otherwise time of descent is greater. Anyways, so you need to know these things. Quickly note that down. Okay, so we discussed what happens when an object is thrown up. What about when an object is dropped down? Okay, not thrown down as such, we'll drop it down. Okay, we'll just leave it. We'll go to a tower and just leave it, right? It will fall. So let's discuss the second case wherein the object is dropped down. So you go to a tower and you drop the object. So in this case, h will be given because you go to that tower, you will know its height. Okay, you'll know its height, and you'll drop it at, you'll just drop it, right? You won't throw it with a velocity, you'll just leave it. You leave it. So initial velocity will be 0, right? Now gravity will pull it and give it some velocity, right? Okay, I'm so bad at catching. Okay, so u will be 0. That is the second point. U will be 0 and g is there only. G exists throughout the motion today. Okay, so one wise thing we can do is to take this direction to be positive and this to be negative. I told you you can take any direction to be positive and other one to be negative. If you are stuck, like if you want to follow the conventions thoroughly, then okay, I'll choose it in your favor. So downward is negative as usual and upward is positive. Okay, so what will they ask in such a case? In such a case, you are supposed to know the speed v. So what is the speed before hitting the ground? Of course, after hitting it will change. So before hitting, just before hitting the ground, what is the speed? So that is what you are supposed to find out. And what else? And also the time, right? Time taken from to reach from here to here. So time t. So from here to here, to travel the entire tower, height of the tower, what is the time taken? So first come first, velocity first. Okay, so we know u is 0, acceleration also we know. Can we use v is equal to u plus at? No, we don't know t. So h we know, no, so we can use v square is equal to u square plus 2as. Okay, now let's go for it. We want to find final velocity. Initial velocity we have just dropped it, right? So initial velocity 0 to a is, you can see that g is negative, it's in the downward direction. Didn't draw g. Okay, g is in the downward direction, minus now h. What is the direction of h? Displacement, right? S h. In this case it is h magnitude wise. And what is the direction? From initial to final. From initial to final. So initial, final. So initial to final, downward direction, initial to final, initial to final, downward direction, negative. So minus h So that's why I wanted to take that positive. Anyways, we get the same answer, 2gh, minus minus plus. So you want to root it. So basically this is the thing that you need to remember. Again, substitute VUAS magnitude only. So substitute the magnitude only. Okay, substitute the magnitude only. So this is how you derive it. Now let's go for time, right? Time. So you can note that down. Time. So how to go for time? Time. So we know the velocity also now. So we can go by the v is equal to u plus at. Yes. Or shall we go by s is equal to ut plus half at square? Suppose we didn't knew the velocity. Okay, we didn't knew this. Then also we can find u is 0. So this term becomes 0, right? We dropped it. How many times should I say that? Half a is minus g, negative g. T is, yeah, that only we want to find, t square. And s is minus h, initial to final, negative, right? So from here you will get t is equal to under root 2h by g. Okay, you can see that minus minus cancels, 2h by g, and that is t square, so under root 2h by g. So these are the things that you are supposed to know from the dropped down portion. Drop down, and throw up also, you are supposed to know those two formulas, I guess. Yeah, two only, I'll say. Remember time of flight, and remember time of flight, and what else was there? Time of flight thrown up, time of flight and the height. Okay. Remember time of flight and height, and time of ascent is basically the half of time of flight. So you can note this down as well. So just basically remember the formulas, so that will make your work easy. Okay, that will make your work easier. So you can go on and practice more of this sort, like direct ones. You will find them in your board practice books, like whatever reference book you use for your boards, you will find such type of question. A ball is dropped from that height, and you are simply supposed to substitute those values, and you'll get the answer, right, if you know the formula. Okay. So we are not going to do that today. So why did we learn that? Okay, anyways, so we are going to try something complex. The previous year questions a little bit tough, but we'll make it easier for you. Okay, so let's do it. Numericals. So not much theory in today's class, as we have already done it in the previous lecture. So a ball is released. So this is the drop down case. Released from top of tower. So we are going to use what we learned today, not like completely neglect it. We are going to use from a tower of height h meters. Now it takes time t. It takes time capital T to reach ground. What is the position from ground? What is the position from ground? Okay, in t by 3 seconds. So 1/3 of the total time taken to fall. In that you have to find a position from the ground. So t by 3 seconds. Okay, I'll give you the options. You can try that. 8h by 9, B h by 9, C 7h by 9, and D 7h by 6. Why is D every time separate? completely out of the box. Anyways, you can try that. It's an IEEE 2004 question. Okay, it has recently appeared in NEET also, I guess. You can try that out. Okay, so you have a tower. I'll do it now. Okay, the correct answer, I guess, is this one. So you have a tower basically. So you drop a ball. So you drop a ball, u is equal to 0. There is gravity on it. So it takes time t to reach over here to the ground. Do you already know that time? Time of drop under root 2 h by g, right? So okay, now now you want to find the position when it's 1/3 of that time. Okay, so first is this time, we already know it to be under root 2 h by g. This is h, right? And we are substituting the magnitudes only, 2 h by g. So we know something about the time under root, so we'll keep that separate. Now we are asked to find the displacement or the distance. Here it's the same since the ball is not changing its direction. Okay, so ut plus half at square we will use directly. So t is t by 3, you can see that. So we'll find the displacement from here first. So displacement, so that is what we need to find, the position. U, initial velocity 0, this term is 0, half at square. So half a is minus g, and you have that t square. T square is t by 3 square. Okay, so you have minus gt square by 2 into 9. So 2 into 9. Okay, so this is what you have, but you want it in a good format, right? So see, the answers are only in terms of h, so you have to substitute this. Okay, so that was the only idea. It's easy now. You substitute, you will get the answer. So s is equal to minus g 2 by 9, and in place of t square you square this, so the root sign will go 2h by 2h by g. G cancels, you 2 cancels, you have minus h by 9. Since the downward direction is negative, we got minus h by 9, but they mean clearly here is h by 9 by magnitude, right? So they have taken the downward direction to be positive. Okay, but I said the correct answer is 8h by 9. Why? So is this wrong? Yeah, it is wrong. Why? Because the question had asked us for the position from the ground, right? This is the position from here to here, right? From here to here. So in t by 3, the ball reached here. So from here to here, it is h by 9. But they had asked in the question about this x, the distance from the ground, so how to find that? So this you want, right? So h minus h by 9, h minus h by 9 is equal to x. So h minus h by 9, 8h by 9. Okay, perfect. Now this is the correct answer. Here you got minus sign because it's in the downward direction. We have taken the downward direction to be negative. Okay, so I hope you got it correct. It was a easier one. Okay, so motion under gravity is known for its good problems. The topic will make you think. It won't be like a specified problem, like you know how to solve it. It will, every time it will make you think. You need to draw the diagram and think for yourself. What way can I do it the best? Find, okay, the next question, find the ratio of displacement. A is displacement in 1, 2 and 3 seconds, 1, 2 and 3 seconds, and B is displacement in first. Now I hope you know the difference between these two, first, second and third. When ball is dropped freely under gravity. So I think this question didn't come, but it will help you solve other questions. So you have to remember the results that we get. Drop freely under gravity. You have to find the ratio. I hope you know the difference between this displacement in 1 second and 2 second and 3 second. This is one thing, and displacement in first second, in second second and third second is a different thing, right? So you can try that out. So no options for this. Okay, now I will do it. So let's divide it into two. Here we'll solve A part. So the ball is basically dropped freely. U is 0, right? You just drop it. You go and drop it. So now you know G is in the downward direction. Now I'll take the downward direction to be positive and upward to be negative, because it will be easier. You can take the reverse also. Doesn't really matter. Okay. So yeah, so you have to find the displacement in the first, second and the third second, the ratio basically. So S1, displacement in first second, so ut plus half at square. So shall we substitute it directly? So basically I'll write it general, and now let's substitute. Ut, you basically know it's 0 for each of those, right? First, second, it's 0, right? First initially it's 0, and then every time it will be 0. For the second also, you begin from here to the second. First second suppose is this much, third second it's this much, right? So basically u is 0 in every case. Initial point is the first from where we drop, so that point u is 0. So u is 0, half. So for the first one, half gt square. G positive direction, downward is positive, t square 1 square, right? For the first. For the second one, half g 2 square. Third one, half g 3 square. Now if you can relate that, it's easier to find the ratio, right? Now you can take the ratios. You can see that half g by 2 will cancel g by 2, g by 2. Everywhere there is g by 2, so that will cancel when you divide, and you will be left with 1 square, 1, which is 1, 2 square, 3 square. And even if you had other seconds, 4, 5, 6, they will be in the ratio 4 square, 5 square, 6 square, is 2 is 2 is 2. Yeah. So every time they will be in the ratio of the squares. So in displacement in first second, displacement in second, and displacement in third second are in the ratio 1 square, 2 square, 3 square. 1 square, okay, no difference. Now B, coming to B. Now this is something different, right? Displacement in the first second, right? Okay, let's visualize that. U is 0. Displacement in the first second, it's this much. Now displacement, this is displacement in 2 seconds, from the first second till the second. But here we want in the B, in the second one B, we want displacement in the second. So it starts from the, when does the second starts? When the first seconds end. And when does the second end? When the third seconds begin, right? So this is S second, displacement in the second, displacement in the first second, okay, and this will be the displacement in the third second. Okay, so basically in each second, what is the displacement? Not over the interval. Here it was over the interval. In 2 seconds, in 3 seconds, interval. So from 0 to 2, from 0 to 1, 0 to 2, 0 to 3. Here it's 0 to 1, 1 to 2, 2 to 3. Getting the difference? Okay. I've already spoke about that in the previous lecture also. Now you need to know the fourth equation of motion. I hope you know that. I'll just write it down over here. You can note it down if you haven't seen the previous lecture, but do check it out. So fourth equation of motion is this: u plus a by 2 into 2t minus 1. T is whatever the second value is, whatever the second is. Okay, at what second, which second. So u, as you know, is 0. Okay, know that u is 0. Now don't consider u of the second to be this. It's over the entire journey, right? U is the initial velocity of the from the beginning. Okay, you can check out for fourth equation of motion. There I have discussed this. You'll know what u means. It does not mean for a particular second what is the initial velocity. It's for the entire thing from the beginning. Okay, so u is 0 in all the cases. A by 2, a by 2. Okay, we'll take it g. So downward is positive, downward is positive. Okay, upward is negative, whatever. So g by 2, and you have 2t minus 1. So 2 into 1, which is 2 minus 1. So you get g by 2 into 1. S second, if you want, you'll get it to be g by 2. Similarly, g by 2 into 2 into 2 minus 1. Okay, so that gives us g by 2 into 3. And if you compute for s third, it will give g by 2 into 2 into 3 minus 1. So that gives us g by 2 into 5. So can you see odd numbers here, 1, 3, 5. So the displacement in here, so where can I write that? S first is to s second. So when you divide all of them, what will happen? G by 2 will cancel. G by 2, 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 g by 2. So all of them are in the ratio 1 is to 3 is to 5. Other seconds, if you had fourth second, fifth second, so they will follow the same trend. 1 is to 3 is to 5 is to 7 is to odd numbers. Here squares, square over the journey, right? In, if you want in displacement in 2 seconds, then you have to look out for the squares. The ratios are in the form of squares, and here it's odd numbers. Okay, so remember this result. Okay, we are going to use it in the next problem. It makes things easier. If you remember a lot of things, it will benefit you at the end of the day. Okay, but yeah, just more of data, but it will help you. So it was not a question as such, but you can remember this. So this ratio you remember, it's for in, displacement in is for displacement in a particular second. Okay, so we'll use that logic in this problem now. Now we have a tap. Nice drawing. Okay, so water is falling from it, drops are falling, 1 1 1. So you have 3 drops over here, right? So something is given, so this is at a height of 5 meter, very above the ground, so much above. Okay, so 3 drops leave at the instant first hits the ground. Third, okay, it's third drop. Third drop leaves at the instant. So when the first drop hits the ground, is about to hit the ground, the third drop leaves the tap. Okay, now each of the drops are regularly coming out. Drops leave regularly, leave the tap regularly. So each of the drops are coming at regular intervals. So the time between this and this is same as this and this. Okay, so suppose it's t over here, here it is also t, and from here to here it will be 2t. It won't it would be irrelevant here because we are going to do it in a smart way. Okay, so okay, drop leaves at regular interval, and finally What is the height of second drop from the ground? What is the height of second drop from ground when third hits? So when the third one hits the ground, you need to find this distance x, right? I won't name it x now. So you have to find this distance, whatever the distance of the second drop from the ground when the third one hits. Okay. So here are your options. First one is 1.25 meter. Second one is 2.5 meter. Third one is 3.75 meter. Fourth one is 4 meter. Okay, you can try that out. So we are going to do it in a wise way. Remove this. Okay, let's first do it by the normal way. Suppose we'll first compute the time. Okay, time for the first drop to reach the ground, right? So what is the time to reach the ground? Basically this, right? 2 under root 2 h by g, it's dropping, right? The drop time, if you remember that. So 2 into h, 5 into g is 10, which is g, you take it to be 10, though it's not mentioned. Okay. Okay, so 2 5s are 10 and 10 cancels, so root 1 1, so 1 second. So it takes 1 second for the drop 1, first drop, to reach the ground, right? 1 second to reach the ground. But what if you wanted to find the regular interval, at which the drops keep falling, right? So once you find the regular interval, then you can use that logic to compute the distance of the second one. Okay, I'm using that logic. First, what I'm saying is, first find the regular interval at which drops are coming. So what was the case initially? If you can visualize it, the initial case was this. Before starting the time, when did we start our time? When the first drop came out, right? When the first drop came out, we started the time, and then the other two will come after t and 2t. Suppose the regular interval is t, so after t this is the case, and after 2t this is the case. Okay, so initially it was just one drop, and then we started our time. One drop was out and we started the time. So basically this is the time for two drops to come out, right? First it was this initially when time was 0. The next two drops came in 1 second. Next two drops came in 1 second. So basically I mean the interval will be this time divided by 2, because 2 drops, right? So half a second. So this is the regular interval. Regular interval at which the drops come out. Okay, so I hope you can visualize that. Initially this was the condition, so after 1 second this happened. So two drops came out, right? Two drops came out, this and this. Actually initially this was the condition. Two drops came out after 1 second, so each drop came after half a second. Okay, so now half a second. Now this drop, the third one, it's just starting, right? It's just starting. So how much time has passed? Half a second, right? From here to here. For this drop, half a second is passed. For this drop, half a second is passed. Since half second is passed, this one is coming, the third one. Regular interval is passed, the next one is coming. Half a second is passed, so the next one is coming. Okay, so for this you apply now s is equal to ut plus half at square. So it's easy now. So we'll take downward to be positive. Okay, so u was initially, it started just dropping, right? Drop, so u was 0, so that term becomes 0. Half g is 10, suppose, and t square is what is that? T is half, right? It took half second to reach here, half a second to reach there. So basically it will give 10 by 8. 10 by 8, I guess it's 1.25. Yeah, 1.25, you can calculate that. But what do they want? So this distance, you found it out to be 1.25 meters. So from the tap to the first drop, right? From the last drop to the second drop, third drop to the second drop. So this distance is 1.25, but they want the distance from the ground. So what do you do? X is equal to 5 minus 1.25, so which is 3.75 meters. Okay, so this was a long approach. You had to think so much. You had to like go for some of you might have divided 3 because you see 3 drops coming out, but it's actually 2. So a lot of things are going on over here. So I'll give you another easy approach to do this. Okay, I hope you have noted that down. That was a long approach though. Okay, so now that logic will use which was used in the question 2. Suppose the regular interval is t, right? So from here to here, second drop came here and the third drop just started coming out. So how much interval passed? T. Okay, from here to here also, how much interval? T, right? When the first drop began, it was time 0. When t seconds passed, the regular interval passed, one more drop came out, the second one reached here. Now again t seconds passed, one more drop will come out, and this one will reach here, this one will reach here. That's happening, right? So basically, I mean, look out for the displacement in first t second. First t second, suppose let's assume it to be x, right? In the first t second, let it be x. Now what will be the displacement in 2t seconds, right? It is like the same previous logic. In 1 second it was x, so in 2 seconds it was 3x, right? Ratios, if you remember. Sorry, in 1 second it was x, in 2 seconds it was 4x. Ratios, 1 is to 4 is to 9 squares, right? In 2t, what will be the displacement? 4x. The ratios were x, 4x, 9x if you had to go on, and here they were like x, 3x. Okay, anyways, you can solve it from here now. What do they want? Okay, I'll keep this over here. They want this distance, right? So 4x minus x, 3x. So they want 3x, but first find 4x. First find x. So you can see that 4x is from here to the ground. You can see that 4x is from tap to the ground, which is 5 meter. Tap is at a height of 5 meter. So 5 by 4, which is 1.25 meters. Okay, you can compute that. And what is 3x? So 3 times 1.25. So 1 into 3 is 3, plus it will be 3 times 0.25, which is 0.75, 75, right? 25 3 is 75, so 3.75. Basically maths. Okay, same answer, right? And this was way easier. So knowing things make motion and gravity way easier. Okay, so if you didn't knew the ratio, you would have gone by that way. You could also mess up things. So knowing data makes it easier. Okay. Okay, so we'll try one more, which is a JEE 2014 question, JEE Main 2014. It was very famous question. So you'll have it in your reference book also, I guess. So it's a ball is thrown with a initial velocity u, okay, and this tower has a height h, so it's thrown upward. You can see that it's not thrown downward. From the top of the tower they have thrown it upward, so it goes up, stops, and comes down. Okay. Time taken by the particle to reach the ground. So time taken to reach ground, time taken to reach ground is n times the time taken to reach highest point, n times the time taken to reach highest point of its journey. Okay, find the relation between find relation between h, u and n. Okay, so you have your options over here. 2gh is equal to n square u square. Find b is 2. Okay, gh is equal to n minus 2 whole square u square. C is 2gh. So don't get frightened by the options. When you do it, it's way more simpler. It's simpler than the previous one, and you'll get the answer in just a few seconds. N minus 2 into u square. Okay, you can try that out quickly. So it's not that tough question. So I have put the conventions over here. It's very easy if you do it. So let's do it. So time taken to reach the ground, so that is capital T, is n times the time taken to reach the highest point. But what is the highest point? So when you throw this upward, right? Highest point, if you see, is this, right? When you throw this upward, it goes upward and it will reach certain height, maximum height, if you remember that. So the time taken for that was time of ascent, right? Time of ascent. Okay, so that was the basic knowledge. So what is the formula for time of ascent? U by G. Without convention, substitute. Now you use, now we have to find relation between h, u and n. So this is basically a data that we got. So I'll use basically s is equal to ut plus half at square. Okay, so not this t. Now remember, for the entire journey the time taken was capital T, capital T. Okay, stay careful about your notations. So u was, so we have taken upward direction to be negative, so u into t. T is this thing, right? We got a formula for t from our knowledge, so you can use that. N u by g plus half, g is positive, downward we have taken to be positive g, and t square, so n square u square by g square. Okay, so here what will happen, so I will take that negative over that side, n u square by g, and you have over here this g and one of the g will get cancelled, n square u square by 2g, right? So one thing you can do is, now this s is h. What is the minimum distance? S is displacement. Remember, not distance, right? It is not the total path length. It is just the distance from the initial to the final. Initial to the final, downward direction, initial to final, positive, and it's h in magnitude. So okay, so we have to find a relation. So what I will do is multiply 2g everywhere. So multiply 2g, multiplying 2g. So where can I do that? I'll do that over here. So I'll multiply 2g to each of the terms. So 2gh I'll get. 2g will cancel over here, n square u square. So you can basically take LCM, but I see the answer, that's why I did it that way. So 2g, when you multiply 2g here, g cancels, and 2n u square is what you are left with. Now take common, so I think C is the correct answer. So n and u you can take common. What will you be left with? N and u square you can take common, so you will be left with n minus 2, right? So 2gh is equal to n u square into n minus 2. C is the correct answer. So basically you had to get this from the sentence, and rest was history. Easy. So let's do the last one for the day. Okay, So these questions make you think, right? So they are not like they have a single way approach. You can think it in any way. Okay, so that's why you need practice for questions of motion under gravity. That's why a different lecture. Okay, so a ball thrown with u in upward direction. So you have thrown a ball with u velocity in upward direction. Can't I just draw it? Okay, I'll explain you the story. So you have to just compute t1 into t2. So you'll decoding part you'll do. So the story is like goes this way. You have thrown a ball upward with a velocity u. So you have thrown a ball upward with velocity u. So it will go to the highest point and then return back. Actually, this is in a straight line. Okay, I'm just exaggerating it. It's in a straight line. Okay, so okay, uh, so suppose this is a point B. They have mentioned a point B which is below the maximum height. So from here to here the ball takes time t1, and for the rest of the journey from here, from B to, suppose here we call it C, so A B C, from here to here it will take time t2. So what they have asked is find t1 into t2, find t1 into t2, basically that. Okay, so I'll give you your options. Find t1 into t2. Website people will be confused what happened to the question. Is it 2h by g, is it h by g, is it h by 4g, or is it h by 2g? Okay, you can try that. It actually didn't come in JEEs, but the intermediate results that we are going to get did come in the exams, right? So this is just an addition. I'll tell you when it comes to that. Okay, you try it. You have to find the product t1 into t2. Okay, done. So option A, I guess, is the correct. Let's check it. I'm not very sure. Okay, uh, so one thing, can you note that t1 plus t2, this time plus this time is total time of flight. Total time of flight. What was the formula for time of flight? 2u by g, right? Time of ascent was u by g. Time of descent u by g. So total time of flight 2u by g. So without any looking at any of the conventions, just substitute. So upward is positive, downward is negative. So for this formula, you don't have to look for conventions, right? Just substitute. Now, what else can you think of? Have they provided anything? No, nothing else is provided. Now you can think that this height is h. Now you have to think this because I told you, no, these questions will make you think, right? So there is no particular way to do a question of motion of gravity. So okay, so you consider this height to be h. So what happens is that you write the equation h is equal to ut plus half at square. So u positive t1 plus from here to from here to point B, from A to point B, you write the equation, plus half g is in the negative direction minus g, and t2 square, oh sorry, t1 square, right? Time is t1. Okay, so you write that. Now if you see, you know about t1, you know about g, the values you know, and you can also see that g is there in the answer, h is also there, but t1 is not there, u is not there. So let's try to eliminate u. So from here we'll find what is u. So half g, so that g goes on top, g. So this was one of the questions in JEEs they had asked, and even NEET, to compute for the time for initial velocity. Same question, they ended it up here. Okay, so that is what I was speaking about. Okay, So that question ended here, but we need to compute T1 into T2. So now let's substitute for that. G by 2 into T1 plus T2 into T1, this T1 minus half G T1 square. Now can you see that this half G T1 square? Now if you want to see that, G by 2 T1 square, this into this, and I'm opening the brackets basically, and you'll get G by 2 into T1, G by 2 into T1 into T2, okay, minus half G T1 square. So plus half G T1 square minus half G T1 square cancels. You are left with H is equal to G, so that was small h is equal to G T1 T2, G by 2 into T1 T2, right? So again, this was another question which had asked you for the h height, another JEE question. So okay, now let's go for the final thing which we wanted was T1 into T2. So this question was not asked, rather I am giving somebody an idea to ask about it. So 2h by g, okay, so A is the correct option. Yes, A was the correct option. So basically, I mean, this question, if you think it had a particular approach, right? So you need to practice more about motion under gravity. They have a particular approach. The questions will make you think, as I said, they will make you think, and you need to visualize the situation. You can also by heart some general results which will help you do stuff, okay? So yeah, there is no way of doing it otherwise. So you need to practice about for motion under gravity. It is not like a particular question, you'll solve it in this way, it will happen. Absolutely no. This thought process is needed, okay? Okay, that's all for today's lecture. I hope you enjoyed it. If you did, hit that like button, subscribe, and yeah, that's all for today's lecture. I'll see you soon in the next lecture. Till then, keep enjoying physics.